So the final case that we want to consider with partial fractions is the case when we have a repeated irreducible quadratic factor. So in other words, our irreducible quadratic, ax squared plus bx plus c, contains the power of r. So this is really just putting together the rules that we had before for the case when we had repeated factors with the rule that we had for the irreducible quadratic factors. So we'll have our partial fractions will have a separate term for each power coming up to the power of r. And because they're irreducible quadratic terms, right, we'll have an ax plus b in the numerator. So here there's going to be two constants in each of the numerators to solve for. And in these cases, it'll be a little bit more work to get all these constants. So once you then have all these constants, then you have to worry about then integrating, which can be another issue into itself. But here, let's just practice this idea with an example that will have a repeated irreducible quadratic factor. So in this case, we've got x times x squared plus 1 in the denominator. So of course we'll have a over x for the linear factor there. But then x squared plus 1 is an irreducible quadratic. And because it's squared, it's repeated. So we'll have bx plus c over x squared plus 1. And then another one, dx plus e over x squared plus 1 squared. Okay, so we have these 5 coefficients that we're going to solve for. So let's try and work that out over here. Notice that in this case, when we clear out the denominators, okay, we'll have on the left-hand side 1 minus x squared plus 1 minus x plus 2x squared minus x cubed equals, and then here on the right side when we clear it out, we'll have the first one is a times x squared plus 1 squared, because the x divides, and then we'll have bx plus c times x times x squared plus 1 plus dx plus e times x. Okay, so we'll use the trick that we did before where we're going to expand everything out here on the right hand side now. So this will involve a little bit of foiling. X squared plus 1 squared becomes x to the 4th plus 2x squared plus 1. Here, before I FOIL, I'm going to distribute the x into one of these here, so it'll be bx plus c times x cubed plus x. And then here we'll have dx squared plus ex. Then I will distribute the a in this one here, so we've got ax to the 4th plus 2ax squared plus a. Here I'm going to do some foiling. Now we've got bx times x cubed, so that'll be bx to the 4th. bx times x, so bx squared. And then cx cubed. And then cx. And now we'll see what can we combine. I noticed that there are some x to the 4th terms that we can combine. So So I'll have a plus b x to the fourth. There are some x cubed terms, or just actually one x cubed term here. I think that's the only x cubed term, but just making sure. Let me double check. Yeah, okay, so that's the only x cubed term. And then we got some x squared terms here, and here, and here. So I'll combine those x squared terms. We have 2a plus b plus d. And then let's see, we have some x terms. Actually just the one, cx. Oh no, and also ex. Okay, so we've got those guys there. C plus ex. And then finally just the one constant term a. Okay. And then I'm going to just bring this down here. We'll match that up term by term here. Okay. Notice that there's no x to the fourth term, so we'll say here that the coefficient of x to the fourth must equal to 0. The coefficient of x cubed is -1, so here we get c must equal to -1. Coefficient of x squared over here is 2, so all this here will equal to 2. Coefficient of x is -1, so this will all equal to -1. And then the constant term is +1, so this value of a will be +1. Okay, so you see there I just matched up each of the terms here. There's no, it's like there's a 0x to the fourth over here, right, that we're missing. So that's why this is equal to 0. We've got a -1 for x cubed, got a 2 for x squared, and we've got the -1 for x, and then we got the +1 for the constant term. Okay, so we're just matching them up. And the nice thing is that a couple of these are already solved. For instance, we've got a is equal to 1. We've got c is also equal to -1. So those ones are already worked out. We've got c plus e is equal to -1 as well. And since we know that c is also -1, that gives us e must equal to 0. So we got a, c, and e. And let's see, since we know that a plus b is equal to 0, and we know that a was 1, that gives me b must equal to -1. So we got a, c, e, and b, and we just need to get d now. So I think I can use now this equation where we've got a and b to get d. Okay, so we got 2a plus b plus d equals 2. We found a was 1. We found b was -1. So I'll write -1 here. And plus d equals 2. And let's see, so 2 minus 1 is 1, and then I subtract the 1 to the other side, and I get d equals 1. Okay. So let's put all those values back into our integral up here and finish it up. So we got a was 1. We got b was -1. And c was also -1, so that'll be -x minus 1 over x squared plus 1. And then here we found d was 1. and e was 0. So it'll just be x, 1x. So x over x squared plus 1 squared. Okay. And now the integral from here will be kind of similar to how we did it in the past. Integral of 1 over x we know is ln x, but before we get there, let's split this one up. Okay, so now we can just do each of these separately now. 1 over x, that'll be ln of x. Remember, x over x squared plus 1 will be minus 1/2 ln of x squared plus 1. Remember, this is 1 over u, or I'm sorry, this is like our, this is our tan inverse. So that'll be tan inverse of x. And this is, oh yeah, this should be squared. Sorry, I almost forgot. So this one we'll do a similar substitution to what we did here, and this will turn into an integral of the form 1/2 integral of 1 over u squared, where here I'm letting u equal to x squared plus 1, so I get du is 2x dx, right? So this part of it here can be integrated by doing the integral of u to the -2, which of course is -1 over u. So here we'll just get minus 1/2 over excuse me, x squared plus 1. Okay, and there we have it.